Generative AI, because they generate text, images, and music, are typically, not always, typically built with large language models. And large language models are a subset of foundation model. So you hear all these terms, right? They're all connected. You know? But they are typically built with large language models, and they try to emulate the brain. Not quite, they try. Yeah? In terms of connections, so let's just say you got all these connections here. The dot on the top left-hand corner is connected to everything on the right, and so on, 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 right? Same with the next group and total. It took me 5 minutes to draw 1,000 connections, right? These large language models have billions and billions of connections, some even trillions. Some are talking about 10 trillion connections. I'll be 1,000 years old by the time I finish drawing those, right? So I did only 1,000. Right? So keep in mind to imagine there are billions of connections here, right? But really these things can be up to 1 trillion connections, even though you're seeing 1,000 here. So generative AI, you send in text, right? And you get text generated. This is one type of large language models. And in this case, ChatGPT does this, right? Way back in February 26, so this is ChatGPT version 3.5, not the version 4, I gave it this. While in the forest, a deer, then I stopped there. I say, complete it for me, right? It gave me this. A very beautiful answer. But the emphasis here is that I decided to try 20 times and pick the most beautiful answer, right? The first answer was a deer was chased by the wolf, and wouldn't sound very nice, the end story of it, right? So the point I'm trying to make here is that a lot of times you hear beautiful answers. It could be because the person tried a few times until he or she finds something he or she likes. Yeah. The next point I'm making is that it did it word by word. So the first thing it did was to just predict dashed. That's it. Right? After that, it took dash and combined it with the original, resends it back to the billions of connections, fire up all the billions of connections, consuming a lot of energy, to predict the next word across. That's it. Right? After that, it combines across with the original, sends it back to predict the next word, and so on and so on. So the next point I'm trying to make is that these things predict things word by word. It's just that it gives you a very good next word prediction. Yeah, later we'll talk about how he come up with such beautiful proses, right? If he just does it word by word. We'll come to that later. But just keep in mind, they consume a lot of energy word by word. Yeah. Okay, in addition to text, generating text, you could put in text to generate pictures. In this case, let me see. Yeah, Mid-Journey in August of last year, someone put in all the text on the left, produced the pictures, sent it to an art competition, won first prize. Big controversy, right? This first prize person, is this person an artist or an author? So think about that, right? Roles are changing. You can be an author to produce pictures. So in fact, the industry is starting to come up with a new term now. They are not photographers, in this case. They are promptographers that produces pictures. So again, terms are changing. So we have to keep in mind, the world is changing. Even roles are changing. Job descriptions are coming up now. Promptographers, look it up after this. Yeah, it's starting to be a term used a lot by photographers. No, you're not a photographer, right? You're a promptographer. Right, there we go. You could also put in pictures and get it to come up with text. In this case, I switched the model from not ChatGPT, not Mid-Journey. I now switch it to Aleph Alpha, German model, right? Their model is Luminous. In fact, the CEO and founder and developer of Luminous is here, Jonas, right? And I was in Germany, on top of a hill in Bonn, where the university have invited neuroscientists and computer scientists, data scientists together to try and look at the future of what AI would be like here, right? And I was in the hotel room up in a hill, nothing else around that I could use. There was an apple. I took a picture. Remember, this is back in September 2022, before ChatGPT came out public, right? Way back, right? And I gave it this picture and kept quiet. So, Luminous, tell me what you think, right? It's an apple on a wooden table. So I liked it because it didn't just say an apple. It gave more context. So already I was appreciating it. Right? Even ChatGPT today, you kind of get access to asking it to read images, right? This thing way back was already doing this. So then I became nasty. I did this. There was a German glasses, I don't know, in hotel room tend to be pretty small. Right? So anyway, okay. I gave it, and guess what it said? It says apple and a glass of water. Now let's put it this way. I mean, humans do make mistakes too, right? And it probably mistaken the line on the glass as it being filled with water. So understandable. So always keep in mind when a model tells you something, always keep in mind maybe humans also do make mistakes. Yeah. Then I went nasty all the way. Yeah. I did this. Now to be fair, right? Yeah. If you just have a human just glance at this, sometimes a human can also make a mistake. I would like you all to internalize what you think the model said. Yeah? Yeah. Just internalize it, and I'm going to show you the answer. September. That's what it said, right? Apple juice in a glass. Okay, the context is right. There is apple, it is in a glass and all. So I asked Jonas, right, what do you think of this answer? He said two things that really got me to have goosebumps, right? He said, I don't really know. And you will hear that a lot, right? Because these models are so big. Luminous is 200 billion connections, right? So big that when it comes out with an output, he's working very hard to make the model explainable. In the future, we'll know why it says this, right? But what's more important for me was that he said Luminous was trained on a lot of humor. So we are not sure if it's actually humoring us. Yeah. So all these are things that tells us that we need to make these models more explainable. And that's what Aleph Alpha, Jonas, is working on Luminous for, right? Especially in regulated industry, healthcare, finance, right? When regulator comes in and say, why do you make that decision? Right? You want to be able to explain it. So this is the focus of Aleph Alpha, and that's part of the reason why we are working with them for enterprises. For consumer is something else, but for enterprises. Yeah. Okay. So how do you put this model on a computer? That's the next thing, right? A server with 8 GPUs, NVIDIA or AMD, right? Let's just say it can handle 100 billion connections. Yeah. Actually, it can handle less than that. I rounded up to 100 so we can remember. Typically 50 billion, some say should be only 20 billion. I rounded up to 100 and I'll eventually be right because these GPUs get bigger and bigger anyway. So let's put it at 100. So if you have a 200 billion connection model, you need 2 of those. If you have a 400 billion connection model, you need a high-performance network and have 4 of those. If you have a trillion connection model, then you need a lot of those. That's part of the reason why we need supercomputing type capability to run these models. The typical cloud world is many workloads running on many computers, compute servers, Google searches and all, many over many. But large language model is one big workload on top of many computers at the bottom. That requires supercomputing know-how to split the jobs efficiently and to make sure your servers are reliable, because if one node fails, your entire workload stops. If you don't have checkpoint restart, you start from the beginning again. Yeah? So it is therefore a requirement to have high-performance computing type know-how to run these well. That's the reason why HPE believes that we can be in this business, even though the Googles and Microsoft of the world are there also, because we have the supercomputing know-how. So let's walk back now to what happens when you have this model sitting on 16 nodes, 32 nodes, 64 nodes. I've seen 128, 256 nodes, one large language model sitting on 256 nodes, imagine. 512 nodes, we've seen one, right? So these are huge models, right? And then what do you do first? You train it on grammar. You consume massive amounts of internet data. Common Crawl, for example, you can download it if you have the disk space, 400 terabytes of 3 billion web pages. Look up Common Crawl, right? Don't click download until you're sure you have the disk space. Or your IT calling you up and say, why are you consuming so much network bandwidth, right? Consume it, and basically what you do, reading all those words, right, about 1 trillion words, right, trying to 1 trillion words coming into this model, what does it do? It basically builds connections. For example, it sees the word deer, and very likely you will see the word bear quite often, because in forests and all. So the link between deer and bear is a very strong one. It has a higher weight. You hear the word weight, parameter. Yes, stronger weight, yeah? But the word deer with the word fly is weaker, because when you see the word deer, it sees the word fly less often than seeing bear, right? And then with turnip, it has a weaker connection. Then I was wondering, why is the connection still there? Shouldn't it be a very thin connection, right? Turns out when I search, Google search deer and turnip, there are people growing turnip to feed deer. Right? So sometimes you get things unexpected. The world literature is so big. Yeah? Sometimes there are unexpected things coming up. So I had to look for one word that is so remote to deer that I can get a very thin connection. So I picked proprioception, right? So it's a very thin connection. Proprioception is a capability of robotics, right? Of humans also, to be able to get your 2 fingers to touch after the second try. Yeah, you can try it yourself here, right? Anyway, this is how it builds. There are 50,000 words, and every word finds a connection with the other 49,999. And then the next word, 49,999. And the next word, 49,999. You work it out, right? That's a lot of connections already, just word to word. Yeah, that's how it builds this understanding of grammar. So that when you give me, when in the forest, a deer, it already knows what is a very good next word. Yeah. Right? Then after that, it learns vocabulary. I mean, in school, we learn vocabulary first, then grammar. This thing learns grammar first and vocabulary, but it does not have a dictionary. It doesn't know the meaning of any word. It only knows that given one word, what's a very good chance that what the next word is. It doesn't know the meaning of that word. It only knows, okay, I shouldn't say that, because there is a linguist in the 1950s that said, his last name is Firth, that said, you know a word by the company it keeps. Don't have to look at the dictionary. He didn't say that, right? But I'm just dramatizing. So keep that in mind, why sometimes these models make things up, because they don't have a definitive definition of that word. It just knows that word knows what that word roughly means amongst all the other words that are around it. Yeah? Imagine going through life, never ever looking up a dictionary and definition of a word, and all you do is keep reading books, and eventually you figure out what each word means. You can misunderstand sometimes. That's what this model does. Yeah? So it's good to understand them, so that when you use them, you understand why sometimes it's acting this way. After that, it goes through a behavioral moderation phase. All right? I mean, reading 1 trillion words from the internet, it could come up to be with a behavior that is unacceptable to society. Right? I mean, you feel it raw, right? I'm going to act like a raw person, right? So it goes through a behavioral stage. And in OpenAI case, they use reinforcement learning with human feedback. And what they do is they hire people, write questions and answers. Question, and this is the polite way to answer. question, and this is a socially acceptable way to answer, and so on, and feed it through the machine, and build a separate or reward model to check the big model. That's the behavior. You moderate the behavior after that. Yeah? And then finally, when you receive the model, you train it for personality by fine-tuning it. Yeah? Be very careful, right? You have to decide if you want to fine-tune it with your personal emails and all that, you're sending it out. You have to understand the T's and C's when you send it out. Yeah? That's why certain companies banned it, certain companies restrict it from company information being sent up, and certain companies are a bit more relaxed for good reasons. You're fine to send it out. Yeah? So this is where you send up your own information to fine-tune that model through an API. Then on the output side, here comes the governance. There are many things to consider here. First, you want to QA it. Just like any product that you produce, you want to do quality assurance. I hear a good saying about this, right? Do not just focus on the complicated things that the model can do. Right? The model can do complicated things, very good. But also concentrate on the simple things it cannot do. Take note of those. It is quite revealing that if you can do so complicated things, give it a complicated question, get a complicated answer that is correct, but sometimes you give it a simple question and it gets it wrong. Those are also very revealing in the QA phase of these models. Yeah? Keep those in mind. These are all best practices and learnings we've gone through. Of course, filter. You've heard people putting barriers here, right? Or guardrails here. And you'll see certain, like ChatGPT being used by Azure. They put guardrails in front, and sometimes they'll say, I'm sorry, I can't answer that question. And then quietly say, if I did, it could be an answer that is socially unacceptable, right? So it stops itself from answering. So you can put a guardrail here, or you can actually put a sentiment analysis AI in front of this model, so that when the model comes up with an answer, the sentiment analysis checks it and say if the sentiment is not acceptable, it will block it. So people are also stacking a sentiment analyzer in front of these large language models as a guardrail. You could also have guardrails here when you're feeding the data. I always recommend that we bring in sociologists and HR people to come in to look at the raw data categories before we feed them, so that they can give you an assessment of, if you use Wikipedia this way, or if you use Common Crawl that way, or if you use US Patent Trademark Office this way and in this proportion, it might be biased a certain way. I recommend you change your proportions a bit. Bring different people in to sign off on the data you train it with. Yeah. Fake mitigation, big problem. I say the toughest job in the future will be journalists. Fact checking. It's going to be really, really tough, right? There are people who are saying, journalists were saying, maybe in the future, we just can't do it alone. It's just too much work to fact check everything, right? As to whether it came from a human or came from a machine, or what proportion of human was in the machine input to come up with this output. Yeah. Some are saying maybe we should crowdsource fact checking. Right? So this is another area that will become an issue. Some are saying that, can I use a model to recognize itself? Whatever it comes out, feed it into a model and say, is it you who wrote this? Right? The problem with that is false positives. That means you're blaming innocent people. Right? So again, it's not foolproof, but all these are just early phases of issues with regards to governance that are coming up right now that we've seen. Yeah. People are talking about watermarking. We do watermark our PDFs today, right? But then every time you come up with a watermark, right, that identifies that this document came from you, right? Someone finds a way to defeat it. Some are saying, could I sprinkle statistical signals in the output so that you can verify that it came from this model, right? So people are now thinking of all these different methods of putting a signature in the output so that it can be recognized. Yeah. Understand the differences. I mentioned a few, right? The biggest one is this. I'm not saying I read a lot, but typically humans would have read in his or her lifetime 1,000 books equivalent of text. I worked it out. It's roughly about 1,000 books. And that's a lot already, right? Some do it in scientific papers, some do it in novels, and roughly about 1,000 books. Do you know how many books equivalent this thing has gone through? 10 million books. That's the reason why it can be creative, especially if you turn the temperature knob up. It can be creative because it has seen more other words in connection than you have in your lifetime. That's its value. Because someone has spent the tens of millions of dollars feeding 1 trillion words into this model for it to be able to connect enough words that you've never seen before in terms of connections. You may know the same 50,000 words, but you've not seen some of the combinations that it has seen. Yeah? That's its creativity. So sometimes we send in something, it comes up with a sentence that, oh no, that's a very interesting way to put things. Because you've only seen 1,000 books. This thing has seen 10 trillion. But keep in mind, the 10 million books you have seen has not a single definition. Keep that in mind also. You have read dictionaries. You have gone through definition of each word by other words. What does this word mean? This model has not. It has seen 10 million books and got really good by just looking at word sequences. No definition. That's the reason why sometimes it makes things up. We call it hallucination. I prefer to use the phrase "make things up," because it roughly, for certain rarer words, right? It might have a wrong interpretation of what that word means. For you, you've looked up a dictionary and you know more exactly what it means. It has not, right? Sometimes, so therefore, during a conversation, it might drift to start making things up. Do understand this. It has not seen a dictionary. Even if you've seen the dictionary, it treats it as a sequence of words, not the words that defines the word in front. Yeah? Yeah? Mm-hmm. Okay. There are ways to fix this, right? First and foremost, you need to be aware. Secondly, you need to prompt. You can adjust your prompts. So if there is one skill all of us here must develop, just like we learn language in school, right? Learn English, learn your local languages, right? You have to start learning how to talk to these models, even if it's in English, to talk the way that will coax the 10 million books of consumption so that you can use it. For example, instead of giving it a straight question and say, solve this for me, you could switch to a better prompt engineering approach and say, solve this for me, but do it step by step, and at each stage, reason for me why that step, and do it politely, right? You could, be more put in more effort in your prompts, right? Tell it more about what you want, and prompt engineering will become a key skill that will be required in many, many jobs. Yeah, keep that in mind, right? And practice so that you can coax out, because this thing, make use of it. You've seen 10 million books, but you need to be able to know how to coax the information you want out from it. Yeah? Yeah. And then there is a temperature button. Some call it a crazy button, right? Some call it a creativity button. If you turn that knob, or not button, but knob to 1, yeah, it will be highly creative. Meaning it won't pick the top word, most likely next word for you. You'll randomly pick from a long list of close potential. That way, your conversation can actually be highly creative. You turn the knob to 1. If you turn the knob to 0, you will be quite a mundane answer. So typically I turn it to 0.8, right? And then go from there, left and right from there. So don't forget the temperature knob, yeah, especially in these playgrounds that you are given. The other area is context windows. These large language models will have big context windows, and you can hear that term. What it means is, if I have a context window of 1,000 words, it means if I prompt with 100 words, I have another 900 words left for the answers, right? Okay, if the answer was 200 words, I have 700 words left. And then if I keep talking, once I use up the 1,000 words, it will start to forget the very first set of words, because it only can remember 1,000 words in the context window. ChatGPT and the latest model, they are looking at tens of thousands of words. Some are with 10,000 words, 20,000 words. You can feed a document. Be careful what you feed, right? But you can feed a document in it first by prompting the following. I'm now going to feed you a document with 5,000 words. Here it is. Then after that, I'm going to ask you a question so that when you answer, you'll be answered in the way that you in the 5,000 words before. When you have a very big context window, you get very good flexibility. And thank you very much. For those who would like the introduction again, is here.